Today I just want to talk about the exterior angle theorem. This is specifically, I'm sorry, I should have wrote this. The exterior angle theorem that has to do with triangles. When we say the exterior angle theorem, we typically mean the one about triangles, but there's exterior angles for all shapes. So first of all, what is an exterior angle? So if I give you a triangle, and it doesn't have to be an equilateral triangle, but I'm going to just put this one out here. An exterior angle would be this, okay? This angle out here would be our exterior angle, right? And if we think about it, if we wanted to, we could really say that, you know, it could be up here, right? It could be, excuse me, just want to keep this consistent. It could be here, right? Or it could be here, right? And there's other theorems that have to do with exterior angles that we'll talk about. But specifically, I just want to talk about this angle today, this angle out here. Now, two things that we need to keep in mind, things that we've said, okay, and they have to do with lines and triangles. They both had something in common, and that is a line, right? We said how many degrees is this all the way over here, right? Well, it's halfway around the circle, right? Right, so that was 180 degrees, right? But one of the things we also said last week was that the three angles of any triangle have to add up to 180 degrees. So they have this in common, that the three angles in a triangle, any triangle, add up to 180 degrees. And if you don't understand that, that you can go back watch the videos from that I posted last week. That should give you a better idea of what that all means. Same thing here. But if you don't know, you know, now you know that if you have two things, if you have a straight line or if you have a triangle, they both have 180 degrees. Using that fact, we can talk about something here. So let's draw ourselves out an exterior angle here. All right, so say we had this exterior angle out here, okay? Let's give these angles some vertices, some names. We'll call this A, B, C, and we'll call this point out here D, okay? Now, we can call this is still angle A in here. This is angle B in here, but we can't call this angle C, right? Because it can be either this interior angle or this exterior angle out here, right? There's two different angles in there called angle C, so we'll have to be a little more specific there. But we know this for sure. We do know that angle A, right up there, plus angle B, way down there, plus, and we have to name this by three letters, A, C, B, right? We want this interior angle, A, B, and A, C, B. In other words, 1, 2, ACB, three angles, right? The sum of those equals 180 degrees, right? But what else do we know? We also know that ACB, angle ACB, ACB, and ACD, in other words, this whole angle out here. So now we're just talking about ACB and ACD. We do know that those two angles also add up to 180 degrees, right? Now, I don't want to get too far into the names of the theorems and things like that, right? But let's think about this for a second. If I said, couple numbers here. If if I said, sorry about that, guys. If I said something like this, if I said, I don't know, some number plus 3 is equal to 8. Right? Well, you first of all, you guys know that that's 5, right? But what if I said some number plus some number plus 3 is equal to 8? Okay. Now this one we for sure know is 5, right? Because we know 5 plus 3 is 8, right? But in this case, we also have to know that while there's different options, right? These two numbers have to add up to 5, right? And it's a kind of tough concept to wrap your head around, that you have options here and you don't have options here. But the bare minimum is this: if I add an equal quantity to some number, there can only be one result. In other words, some number plus 3 is equal to 8. That number has to be 5, right? Now, whether it's one number or two numbers is inconsequential. And you get the same thing here, right? If A and B plus ACB equals 180, and let me move these around for a second, right? Kind of line these up a little bit better. And I said that ACD plus ACB equals 180 degrees, right? In other words, what we're saying for A, B, and C is 180 degrees. A, C, D, and ACB is equal to 180 degrees because it's a straight line. Again, I'm adding the same number, right, ACB, to these two things, and I'm getting 180. Therefore, the big thing we can take away is I know that ACB, angle A and angle B, when I add them together, they have to be the same thing as ACD. And I know that because when I add both of them to ACB, I get 180 degrees. Okay, so bare minimum. Okay, and I'll make this as clear as possible. Okay, sorry if I got a little confused in that for a second. If I go ahead and I make this as simple as possible, I have angle 1, angle 2, angle 3, and angle 4. Angle 1 plus angle 2 is equal to angle 4. Okay. In other words, not the one that makes the supplemental angle with it, not the one that makes 180. These two added together makes this one out here. So let's take a look. Say I'm given something like this. Okay, what's the measure of angle 1? Well, the measure of angle 1 is equal to the two angles that are not part of the one that's supplementary. Okay, so angle 1 is equal to 44 plus 40. So the measure of angle 1 is equal to 84 degrees. Now, if you didn't know this specific rule by name, it's not like you couldn't find out, right? Well, let's think about this. I know that this is 44 and this is 40, right? So I know that these two combined, when I add them together, these two right here, this would be 84, right? Which means what? I know that there has to be 180 degrees here, so I know that this one has to be 96, right? 96, 44, and 40 make 180. Well, again, what do I know? I also know that 96 plus 84 makes 180, right? So you could figure this out without having to do it. It's no big deal, but choose the shortest way to the end of the problem, I think. Okay, here again, angle 1 is equal to 31 degrees plus 118 degrees. Okay, sorry, I left the degrees out of the last problem. Okay, so 31 plus 118 is going to be 149 degrees, right? So big obtuse angle there. Okay, obviously they're going to be a little more complicated. What do we know now? Again, these are still year 2 angles over here. Guys, if I know it's hard and we normally do these on paper, but you can always redraw it this way if it helps you. I normally tell you guys to rotate your paper if you need to, but obviously, you guys rotate your phones, your computer screens, right? But again, what do we know? We know that W plus 18 plus W minus 10 is equal to W plus 48, right? These two add up to this one. So W plus 18 plus W minus 10, W plus 48. What do I get? 2W plus 8 is equal to W plus 48. Subtract W. W plus 8 is equal to 48, or subtract 8 from both sides. W is equal to 40. Okay? All right, and last one here. Again, what do I got? I've got V plus parentheses V minus 41 is equal to V plus 49. Okay, again, V plus V minus 41 is equal to V plus 49. 2V minus 41, subtract a V. V minus 41 is equal to 49. Add 41. I'll find out that what? V is equal to 90. Okay? Okay, and again, that means that this is a right angle here, which looks to be about right. Okay? All right, guys, you should be able to take it from there.